Okay, good afternoon. So let us continue with this problems. So this problem that I want to solve is the exam problem 2021, as you see on the board. Uh, 0107, question number 4. Question number 4, part B. So a function is given to you, so f of x is equal to ln of x over x squared. And then you want to see if these improper integrals converge or diverge. So one of them is integral from 0 to 1 f of x dx, and the other one integral from 1 to infinity f of x dx. Yes, both of them are improper integrals. Why? Here, if x goes to 0, this limit becomes infinity. Yes, and this is improper because the interval is unbounded. I don't know how much you know about calculating integrals. I told you that sometimes the integral is hard to calculate. Then, of course, we have to invoke other methods to see that if they diverge or converge. But might be the first attempt that you may start to think at least about it is that, can I calculate the integral? Because if I can calculate, I don't know if you are experienced, I don't think that you face a very big problem in calculating this integral. And then if you can calculate this integral, then you can consider this improper integral and this improper integral by a limiting process, yes? So let us try to see if we can solve that problem. So can we calculate this indefinite integral ln of x over x squared dx? So if you want to choose a method to solve this one, which one do you prefer? What do you think about solving this? Which technique is, based on the experience that you got so far, which method is more reasonable for this? Substitution with which function? Ln of x to be u, and its derivative is 1 over x. It does not appear exactly there, so I wouldn't go for substitution in the beginning. But it seems if x squared was not here but here, then I think we already solved some problems similar to this. That was integration by parts. Okay, so let us try to see if integration by parts work here as well or not. Okay, so what I do, I would reorganize it like this. And then what I do, I will take this one to be u and this part to be dv. Yes, so what I do, I would say that, okay, u is ln of x, so this implies that d of x is equal to 1 over x dx, and then I take the other part to be dv, 1 over x squared dx. Then this implies that what is v? V is the integrand of this, which is a very simple problem. It becomes minus 1 over x. Then I use integration by parts, so let me call this one I. So I becomes equal to u times v, which is minus 1 over x ln of x, minus integral from integral of v du. Sorry, this is not dx, this is du. So minus v du, but v has a minus sign here, so I pull it out, it becomes positive, and this one will be multiplied by du, which gives me x squared. So you see that this becomes very elementary integral, yes, so we can calculate it. So this becomes minus 1 over x ln of x, and this integral is also minus 1 over x. So this is integral I. This is one primitive function for this I. And now I can answer both questions with this integral, with this solution, yeah? So I would say that if you want to calculate this, integral from 0 to 1 f of x dx, I have problems at 0 because when x goes to 0, this function becomes unbounded. So it's an improper integral of the second type. So what I can do, I can just write the limit. Instead of going from 0 to 1, I go from epsilon, for example, to 1, and then f of x dx. But I have to send epsilon to 0 from the right-hand side. This is the definition of type 2 improper integral, yes? But I have already calculated this integral, I, so I have to put this there and calculate it between epsilon and 1. Okay, so this becomes equal to the limit of epsilon goes to 0 from the right, and then I would write minus 1 over x ln of x minus 1 over x calculated between epsilon and 1. Okay, so I have to replace x everywhere with 1, then replace x everywhere with epsilon, subtract them, and take the limit. Yes, but when I put 1 here, ln of 1 is 0, so this is gone. It becomes minus 1 over 1, which is minus 1. So this becomes the limit. Epsilon goes to 0 from the right, so minus 1. And then minus, I have to put epsilon instead of x, but the minus that I bring in will cancel all these negative signs. So this becomes 1 over epsilon ln of epsilon plus 1 over epsilon. So I have to calculate this limit. So I don't know how do you want to do it, but for example, let us just do it like this. Epsilon goes to 0 from the right, and I can take the common denominator between these two, for example. Let me see which one is more suitable. So here, if I write okay, so this is not actually, so let me write epsilon here, and then I have epsilon 1 plus ln of epsilon, and then I have minus 1 there, yes? This is something that we write, yes? And then epsilon goes to 0 from the right-hand side. The numerator becomes minus infinity, but that is infinitesimal, so that is actually nothing indeterminate, because when I send epsilon to 0, the denominator becomes an infinitesimal, a small number, and the numerator becomes minus infinity plus 1, which is minus infinity, but infinity divided by an infinitesimal even becomes bigger. So there is no indeterminacy going on, and the answer becomes just minus infinity. Yes? So the answer to this is minus infinity. So I would say that yes, this integral diverges to minus infinity. Could you predict that the answer should be negative? Because I was a little bit doubtful, but I realize it makes sense now. Because x squared, which is the denominator, is always non-negative. And on this interval, ln of x is negative. So this means that if it is supposed to be an infinity, it should be negative infinity, not positive infinity. Okay, and then we go for the next one. For the next one, I have to calculate this. So this is an improper integral of the first type, so I would write ln, a limit of 1 to r, f of x dx. But this time I send r to positive infinity. But I have already calculated this, so instead of this expression, I write that ln of x minus 1 over x. It is supposed to go from 1 to r, and then at the end, I have to take the limit and send r to infinity. So what happens here, so this becomes, I put r, it becomes minus 1 over r, ln of r, minus 1 over r. And then minus, I put 1 here, that becomes 0, this becomes minus 1, but because of that minus sign, it becomes positive 1. And I have to take the limit when r goes to infinity. 1 over r when r goes to infinity is 0. Ln of r will be dominated by this r, so this limit also is 0. If you don't like it, you can take the Orbital's rule, use the Orbital's rule, you immediately get that is also 0. So the answer to this is 1. So this integral converges to 1. This integral diverges to negative infinity. Yes? Is that clear? Okay. Now let us go to the next problem. That problem is also interesting. So we were supposed to calculate the limit of this sequence an, which is defined in this way. So that is exam 2021. Um, 0311 and question number 6, I suppose. Yes. So we are supposed to calculate a limit of this sequence. The sequence is 1 over n to the power of 1 over n squared multiplied by 1 over n to the power of 2 over n squared, and then multiplied by 3 over n, so I made a mistake here. So that's also 2 over n. Okay, let me have my paper with me. I cannot see it. So 1 over n, that's correct. That's also correct. 3 over n to the power of 3 over n squared, and then it continues until nth term. Yes? So we want to calculate the limit of this sequence when n goes to infinity. This is the question. So you see, this is a product, not a sum. For these limits, we learned how to calculate limits using by translating the problem into the language of a Riemann sum, and then use the integral to answer that question. But this is not at all a sum. Yes, it's just a product. So do you have any idea what to do? It's not a sum, but you want to turn it into a sum. What operation is good here? An operation that takes a product from you and gives you a sum. Yes? Logarithm. So it's natural. Yeah. So I would say that let us take ln from both sides. So I will take ln of n is ln of this expression, but ln of the product of some numbers is the sum of the ln's of those numbers. Yes. So this becomes ln. Let me just write it in 2 steps. The ln of the first number plus the ln of the second number, and then plus ln of the third number, and it continues until the ln of the last number, n over n to the power of n over n squared. In the next step, what I can do you remember this is a property of ln, so this number, which is the power of this one, can go back. So it becomes 1 over n squared, ln of 1 over n, plus 2 over n squared, ln of 2 over n, and then plus 3 over n squared, ln of 3 over n, and then you continue until n over n squared, ln of n over n. Yes? And now I think it is more familiar to your eyes, because that's more or less like the pattern that we have studied so far. Yes, I told you that it is better to write it in a sigma form so that you can actually understand it better. So I will continue, and I would write that ln of an is equal to, if I want to write it as a sigma, you can immediately see that this becomes sigma. K goes from 1 to n. Yes, so I have k over n squared, then I have ln of k over n. Yes? Is that understandable? So I can write this compactly using the sigma notation in this form. If I put k equals to 1, it generates the first term. If I put k equals to 2, it generates the second term, and until the end. And then you remember we had a formula before, which I told you that most of the problems in the exam, more or less without exception, is using this particular Riemann sum. And the Riemann sum was, do you remember, the limit of 1 over n sigma f of k over n, and then k goes from 1 to n goes to infinity. If this function f is integrable on the interval from 0 to 1, the answer to this limit we learned before. I don't need to repeat it anymore, but of course in the exam you have to motivate this formula every time to use it, okay? But we already know this is the formula we had before under this condition that the function f is integrable. In that case, I can write this in this form. Of course, you see that this sum is very similar to this sum. The only problem, at least we see, is that I need a 1 over n, and that is good because I have an extra n here, so I can pull it out. So this becomes the limit. So sorry, let me just write it one more step. It becomes 1 over n sigma, k goes from 1 to n, k over n, ln of k over n. Yes? And now let us take the limit. I know that my goal is to calculate the limit of a of n, but let me calculate the limit of ln of a of n. You are also familiar with this trick, hopefully. We did this before when we were talking about indeterminacy of these forms. You remember 1 to the power of infinity or infinity to power 0. We learned how to use this trick there. Okay, so what we do, we take the limit of ln of an, n goes to infinity, is equal to the limit of 1 over n sigma k over n f of k over n, k goes from 1 to n and n goes to infinity. Yes? Now hopefully, oh sorry, this is not f, this is ln. Okay, so now hopefully if you compare this with what you have here, you immediately can guess your function. Yes? So what the function is, you need to guess a function so that f of k of n becomes k over n multiplied by ln of k over n. So what that function is? X ln x, yes? So this becomes, so if I take f of x to be x ln of x, then this is nothing except f of kn. So this limit becomes equal to the limit of 1 over n sigma f of k over n. K goes from 1 to n, n goes to infinity, if I take this as my function. Yes? But there is a small problem here. What that problem is? Yeah, so this function, it might be integrable, but you remember so far, whenever we guess a function, that function was continuous, and then we concluded that the function is also integrable because continuity implies integrability. Here, this function is not continuous on the interval from 0 to 1 because I have problems when x is equal to 0. When x goes to 0, this function is not bounded. It is unbounded function. Okay, I know that this is a problem. We have to address that. But for the time being, let us ignore that and see what happens. Okay, I will come back and answer that question as well. But for the time being, we know that this function is not continuous on the interval 0 to 1. But I tell you that this function, even though not continuous, it is still integrable. Okay, so this means that this can also be applied here. Okay, but I will come back and try to fix this problem. Okay, so this becomes equal to the integral from 0 to 1, my function dx. Yes? But still, let me just put a question mark on it. The only thing that we have to address is that the integrability of this function, I need to convince myself about it. But other than that, there are no problems here. But then immediately you see this integral is a type 2 improper integral. Yes, because the limit of your function, the function is not actually defined at 0. Okay, so what we do what we can do, we can write it as integral from epsilon to 1 as before, and then calculate the limit when x goes to, when epsilon goes to 0 from the right. But this is a famous integral. Hopefully you remember this is integration by parts. So you can calculate it using integration by parts. So here you take ln of x to be u, and then you take x dx to be dv. Yes? So u is ln of x. Then what happens? Du becomes 1 over x dx. And then dv is x dx. So this means that v is x squared divided by 2. So the integral that I have, x ln of x dx, becomes u times v, which is 1 over 2 x squared ln of x. Yes? And then minus v times du. But v has a factor of 1 over 2. I pull it out. And then this x squared will cancel that x, so it becomes x dx. Yes? But this is also very trivial because this becomes x squared divided by 2. So it becomes 1 over 2 x squared ln of x minus 1 over 4 x squared. Yes? Okay, let me double check everything. So I took this to be u and then the rest of it dv. So v becomes x squared over 2. U times v, I have written it correctly. And then 1 over 2 is out. This is cancelled. It seems to be right. Okay, but now I have to calculate it between epsilon and 1. So this means that if I want to calculate this one, so let me use the board. So I calculate it here. I put 1 instead of this expression. Ln of 1 is 0, so this becomes minus a fourth, minus 1 over 4. And then minus, I put epsilon instead of x everywhere. So this becomes minus 1/2 epsilon squared, ln of epsilon, and then I have plus 1 over 4 epsilon squared. Yes? Yes, that's correct. And now I have to take the limit and send epsilon to 0 from the right-hand side. Okay, so what is the limit of this part? So taking the limit of epsilon going to 0 from the right. So let me write the terms. I have 1 over 4 epsilon squared. I have minus 1 over 4. And then I have minus 1 over 2 epsilon squared ln of epsilon. Okay, so this one will vanish when epsilon goes to 0 from the right. The only problem is that to calculate this limit. What type of limit is this? When epsilon goes to 0, ln of 0 goes to infinity, and this is 0. So this is a 0 type infinity indeterminate form. So I have to lift that indeterminacy to be able to answer that question. So I don't know what is happening actually. Okay, so what should I do? So let me concentrate on calculating this limit and then we put back everything there. So limit of what is supposed to be calculated, it's minus 1/2. So let me just calculate this part and then we put it back. Epsilon goes to 0 from the right. So if I put 0, this is 0, ln of 0 in minus infinity. So 0 is infinity. Do you remember how should I use Orbital's rule to do this? If I want to use Orbital's rule, I bring it down. This becomes ln of epsilon, and this becomes 1 over epsilon squared, and epsilon goes to 0 from the right. And now I use Orbital's rule, because now it is infinity over infinity. I can use that. So this becomes the limit. The derivative of this with respect to epsilon is this, and the derivative of that is this. And if you calculate, this is 3. And if you calculate that, epsilon goes to 0 from the right. So this becomes the limit minus epsilon squared over 2. Epsilon goes to 0 from the right, so this becomes 0. Okay, so the limit of this part is 0. Okay, so the limit of that part is 0. The first part is 0. So what is left is minus 1 over 4. Yes, so this means that the integral from 0 to, so the question mark that I was to calculate, integral from 0 to 1 x ln of x dx, yes, is actually equal to minus 1 over 4. But be careful, if you haven't missed what we have done so far, we started actually here and take the limit. So what I am calculating is not the limit of this sequence, is the limit of the ln of that sequence. You see it's here. It's the limit of the ln. I got it to be minus 1 over 4. But I want to calculate the limit of a to the power of n. Yes, but a to the power of n can be written as e to the power of ln of an. N goes to infinity. Yes, because e to the power of ln of an is just an. But now we know that e is a continuous function, so it means that I can send this limit up there. So you need to mention this, that because the exponential function is continuous, it doesn't matter if I take the limit from the exponent. But we already calculated the limit of the exponent. It's minus over 4. This becomes this limit. So if you want, you can simplify it to 1 over 4th root of e. So that would be the limit. Yes? Is that clear? Okay, so if I go back here, so this function is not continuous, but this function, if I define it artificially, so let me define a function g of x to be x ln of x if x is not 0, and 0 if x is equal to 0. Okay? So the difference between this function and the original function f of x that you see here is exactly at one single point, and that is x equals to 0. That function f is not defined at 0, so it is not continuous there. But this function that I defined is defined at 0, and I showed that this is not only defined but also continuous at 0. If I want to check if this function is continuous at 0, how should I check it? I have to calculate the limit and show that the limit coincides with the value of the function. Yes? So if I ask you what is g of 0, you will say that g of 0 is 0. If I ask you what is the limit of g of x, when x goes to 0, because when x goes to 0, it is guaranteed that x is not equal to 0, I use this rule, and this becomes the limit of x ln of x, x goes to 0. Exactly with the same method that I used here. Instead of epsilon, you put x. Instead of x squared, you have just x. Exactly with the same way, you will find this limit is also 0. And then it means that the limit of g of x when x goes to 0 is equal to g of 0. So this means that this function, first of all, is a function which is continuous in its own domain. And also, if it is continuous, by the way, it's also integrable. Remember, g of x is integrable. But what is the difference between this function and that function? These two functions only differ at one single point. And this is also a theorem. If two functions differ only at one single point, if one of them is integrable, the other one is also integrable, and the value of that function, the value of that integral coincides with the value of the other integral. So what I'm saying is that this function is not continuous, so it is not yet guaranteed to be integrable. But this function is continuous, it's guaranteed to be integrable. This function and that function only differ at one single point, which is x equals to 0. So this means that if g of x is integrable by a theorem which can be proven, the function f is also integrable. And then you can imagine it like this. Instead of imagining this to be a Riemann sum of f of x, you can say that, okay, this is also a Riemann sum for g of x. So you can actually transfer everything about f to g, and then you know how to actually do it. Yes? Understandable or not? So the logic is a little bit convoluted here. So in principle, you should say that, okay, this is a Riemann sum, not for this function. This is the Riemann sum for this function, because it doesn't matter if you have one single point. When you have this interval from 0 to 1, and you start partitioning your interval, what is a Riemann sum? A Riemann sum is, you need to choose a tag here, okay? And in this case, you have already chosen the right-hand side points as tags. And this 0 is a left-hand side point. So if you say that that is a Riemann sum for this function, it is also totally acceptable, because that is a real Riemann sum for this function as well. Yes? Yes or no? Are you convinced or not? Okay, but the logic, you should be careful. Anyway. Okay, so if you don't have questions, let me just continue. But I want to go a little bit faster about these things. And I think I will start solving some problems for you rather than actually teaching you a lot. We want to use integrals to calculate areas. Okay, so I have given you a picture here. So let me try to draw that and try to together at least to start finding that area of the colored region. So, yes. Whenever I see the solutions written by examiners, they're actually explaining that this is a Riemann sum for that function. Yes, at least you need to tell this, that this is based on a Riemann sum. Yeah. Okay, so the functions, so you see that we have a line here, another line here, and then I have a curve here. I don't be able to draw it precisely, but let us just draw this. We want to find this area here. Okay, this function is 3 over x. This function is also 3 over x, and this function is y equals to x plus 2, and this function is y equals to x minus 2. Okay, so do you remember that? By the way, let me just review a little bit. If you want to calculate areas, do you remember if you have something like this, a function which is always positive, and then if function is f of x, and then you want to calculate this area, so this area is exactly equal to the integral from a to b f of x dx. Okay, but be careful, because integrals can be negative, but areas cannot be negative. Yes. Okay, so for example, it is clear that if I have this scenario, and this is my function here, and this is a, and this is b, and this is a, okay? If I calculate the integral from a to b f of x d of x, because if someone asks you what an integral is, you would say it's the limit of a Riemann sum. Okay, and a Riemann sum is what type? Is a sum of this, yes? Something like this. So if your function is negative always on that interval, this means that all the values of FCIs will also be negative for any choice of tags, yes? And then delta xi are the lengths of the subinterval, so they are always positive. So in this scenario, because all the values of my function in this interval is negative, so the sum will also be negative. So eventually the integral is a negative number. So be careful. So integral is not exactly the area. It's closely related to the area, okay? But in this case, the area becomes negative of this integral. Okay. And then what happens, for example, if I have, I don't know, for example, if you have something like this, is from A to B, and let me consider this part area number 1, this part area number 2, and this part area number 3. And if I ask you, relate this integral from A to B, f of x dx, to these values. When I say these are areas, I mean that they are positive. By definition, area cannot be negative. But if I give you the values for these areas, and I ask you to calculate this integral, how do you proceed? So you would say that this part is above the x-axis, so I bring it in with the positive sign. But this one, I would write minus a2, and then this one, I would write positive a3. Okay, so be careful about this. So if you start adding those three numbers, so when I say area, I give you a positive value for the area. But if I ask you to calculate the integral from A to B, if you just write A1 plus A2 plus A3, that turns out to be wrong. So you have to write A1 and A3 positive because they're lying above the x-axis. And then the one which is below, you have to write minus A squared, minus A2, something like that. Understandable here as well? Okay. And then what happens if I have the area between two curves, for example? Something like this. If this is the function f of x, and this is the function g of x, and then for example, I am interested in calculating the area, here is A, and assume that here is B, and I am interested in calculating the area between these two functions. So what should I do if this is the area? Area is the integral from A to B, the function that lies above minus the function that lies below, and then integrate it. Okay? Because you have already studied this, so I don't want to spend so much time on it. Okay? Okay, for example, first of all, do you understand that I have written y equals to 3 over x and y equals to 3 over x? This is clear because if you draw the graph of that function has two branches. Yes, please. Yes? Yeah, it doesn't matter in this case. So when you want to find the area, what matters is that you write the one above minus the one below. Even if it goes below, it will automatically be taken care of. Yes, but not for the volumes. For the volumes, these two should be upside. We will come back to that a little bit later. Yes. No, that the point is that you have to, just memorizing the formulas are not good. So you need to immediately be able to interpret the area as a Riemann sum to get a feeling how you can calculate this, yes? And in that case, let me, for example, in this case, so this area is not one of these standard types that I have mentioned for you here, yes? So if you want to find this area, so you yourself have to divide it into some pieces so that in each piece you can use one of these rules to calculate the corresponding area and then add them together. Okay? So for example, this area, if you see, I don't know, do you have an idea how to do it? I don't have the precise picture here. It might be, yes. So I will actually draw this line. So it gives me one area here. Yes. And then I can also draw this line. Okay, it will give me an area here. And then I have another area here. Yes. So I can calculate these three areas. And when I finished, I add them up and I will have my area. Yes. And I think based on symmetry, you can immediately realize these two will be the same numerically. So I need to immediately calculate only two areas. Okay, so let me call this one area number 1 and this one area number 2 and the middle one area number 3. Okay, so for example, let us calculate area number 1. So you see area number 1, if you want to have a better understanding, you just draw a very narrow strip here. The thickness of this narrow strip this is x-axis, the horizontal x-axis is x, so this narrow piece is actually dx, the very short length of an interval on the x-axis, I call it dx. So this is the thickness of this strip, and then I need to know the height, because if I know the height and if I know the width, if I multiply them, it will give me the area of very narrow strip here, and using integral, I will start adding these narrow rectangles together and find the total area. So that's the idea. Okay? Of course, you can understand it, which is better, or you can use this thing, because now this strip lies from above on this curve. Of course, in this case, it's a straight line, and it lies on this curve from below. So that's exactly this scenario going on here. So if I want to calculate area 1, so what I do, I write integral. I write the function above, which is x plus 2, minus the function below, which is 3 over x, and I integrate it. Yes, so dx, you should interpret it as this thickness, and x plus 2 minus 3 over x, you should interpret it as this length. And it is clear, yes, because this is, so if you want to find, if you have 2 points, this is y1, this is y2, if you want to find this length, what do? You write the number above minus the number below. It will give you the length, even if this number is below the x-axis. For example, let us assume that this point y1 is 1 and this point y2 is minus 2. If I ask you what is this distance, the distance is the number above minus the number below. It automatically takes care of the minus sign and it becomes 3. And 3 is correct because the distance between 1 and minus 2 is indeed 3. Yes? Okay. So you calculate this, but the limits you need to find yourself. So one limit, so the starting point of this area, of this region, is here. So I need to understand where this point is, and I need to understand where this point is. So because the limit of integral, so the limits goes from this point to that point. So these 2 points I need to calculate myself. Okay, so how should I calculate? That is also simple, because this point is the intersection of this line with this curve. So let us just put them in a system and solve that. So this becomes y equals to x plus 2 and y equals to 3 over x. So I equate them, it becomes 3 over x is equal to x plus 2, and then it becomes x squared plus 2x minus 3 equals to 0. And if you solve that, it becomes 1 and a minus 3. Okay, so which one is acceptable here? Only the negative sign is acceptable. Why we get 2? Because of course it is clear there is another point here. So this 1 and minus 3, I have 2 intersection points. Yes, you see this line and this curve, which is one equation, but it has 2 branches. Yes, it has 2 intersection points. One of them, x is minus 3 according to the calculation, and the other one is x equals to 1. But the 1, I don't need it in this case. This means that this number that I was looking for is minus 3. Yes? Understandable? Okay, and then I need to know this point. So how should I know this point? This point is the intersection between these 2 curves, and this line and this curve. So I set up a system with this curve and this line. So I will set up a system y equals to x minus 2 and y equals to 3 over x. I put them in the system, so this becomes 3 over x is equal to x minus 2. So this will imply that x squared minus 2x minus 3 is equal to 0. Again, I get 2 answers, minus 1 and 3. But in this case, which one is acceptable? I am on the left-hand side of the y-axis, so this is minus 1. So this means that I should go from minus 3 to minus 1. Yes? Okay, and I don't want to continue the calculation because the calculation is very trivial. This is just x squared over 2, 2x, and this is minus 3 ln of x. Not be, by the way, not 3 ln of x. It is crucial here. Always you have to write ln of absolute value x. Otherwise, you will be in trouble putting negative numbers there. So always remember to put absolute value for x. And then, of course, in this case, a2 is also the same number. Okay, because of symmetry. Of course, if you don't rely on symmetry, you have to calculate it once more and finding those things. Okay, now can you tell me how calculate a3? I want you to help me to write. Just writing the integral is important here because calculating integrals are actually trivial at this point. So how should I write the number? So how should I find area 3? Area 3 is between these two vertical lines and these two functions. Yes? So I have to subtract the functions. The function above is x plus 2 minus the function below and then dx. But I should go from here, which is minus 1, up to that point. So do you remember what that point is? So it goes from minus 1 to which point? So we calculated, we put 3x and this into one system. So it is a positive 1. Okay? And then this is actually extremely simple because x is gone, so it becomes just 4. Yes? And that is also reasonable. Why it is always 4? Because it doesn't matter. This length remains the same, and that is always equal to 4. So the width is dx, and the length is always actually 4. And then you calculate and add these two together. Is that clear? Yes? Okay. But the next problem is a better problem. I chose it from Adams. And then the next one is a module problem, some similar to exam problem. So we want to determine the exact area of the region enclosed by this straight line, y equals to x, and two functions. One of them this function, and the other one negative of that function. Okay? So in principle, they don't ask you to draw the graph, but if you are able to sketch the graph and to see the region in front of your eyes, it would be easier for you to solve the problem. Okay? So I want to solve this problem from two perspectives. At least I want to write the integrals from two perspectives, and then you see that one method is much, much easier from calculational point of view from the other one. Okay, let us try to understand this problem. So for example, at this level, you should have the graph of this function in mind. This is a very standard one. So what is the graph of this function? It is something like this, yes? Something like this. Or at least you should be able to immediately understand that. So what is the only difference between a square root of x plus 12 and a square root of x? It is being shifted, yes? 12 units, but because this is positive, it has been shifted to the left. So this means that if I want to understand the graph of that function, it is just, for example, assume that here is minus 12, 12 shifted to the right, and then I will get this one. Yeah, something like this. We don't need to be very precise. For example, if I ask you what is this height, you can answer me by putting x equals to 0, and this height becomes square root of 12. Okay, but now if I could draw that, what is this graph? This is the same graph multiplied by a negative sign. So it means that every y value becomes opposite. So this means that this becomes the reflection of this curve, yes? So this branch is the square root of x plus 12, and this branch is minus the square root of x plus 12. And then y equals to x is also famous. Everyone knows that this is the bisector. Of course, this is not a very good bisector, but assume that this is the case. So now you want to find the precise area bounded by these curves. So what is wanted is actually this colored region. Yes? But I intentionally, I want you to see it from two perspectives. Okay? So let me go first the longer method. I do not solve the integral, but I want you to understand how to do it. Can I, if I want to look at it in this way, can I write just one single equation to find that? One single integral to find the area? Because I want you to teach you that you can see the problem vertically, or you can see it horizontally. And always be ready. Sometimes one of them is superior to the other one from calculational point of view extensively. Okay, if I want to do it as normal, I want you to understand that you have to divide your area. Because you see that this part that I am drawing a line here, on the left-hand side, this area is enclosed between this curve and that curve. One of them has this equation, the other one has this equation. But when I pass this threshold, the area is limited by this curve, but this line. Okay, so this is the motivation. If you want to look at the problem vertically, you have to understand yourself that you have to divide your area into two pieces. Yes, because when you start from here up to here, it is squeezed by these two curves, and then when I go forward, this remains the same, but this graph below will change to a line. Okay, so if I want to solve it in that way, so can you tell me how should I calculate the integral? So let me write this one A1, and let me write this A2. So help me to write the formulas only. So can you tell me what should I do for A1? I should write integral. From where to where we can discuss later. But what should I write first? The curve which is above minus the curve which is below, yes? The curve which is above is the square root of what? X plus 12 minus the curve below is minus the square root of x plus 12. Yes? And then dx. Okay? But then I also need to know the limits. So what is the lower limit in this picture? This starts from here and goes up to there, yes? So it starts from this point, which is minus 12, and it starts going up to this line. So how should I find this x-coordinate? I see that this is the intersection between this and this curve. So I need to find that intersection. So what I do, I set up a system. On the one hand, I have this. On the other hand, I have y equals to x. Okay, and then you solve this problem. So this becomes square root of x plus 12 is equal to minus x. I square it, so it becomes x squared minus x minus 12 equals to 0, and I factorize it. Yes, am I right? Yes. So it becomes positive 4 and negative 3. Positive 4 is not acceptable because positive 4 makes the left-hand side 16, the right-hand side negative 4. It's not acceptable. So the answer is negative 3. Okay, so this goes from minus 12 to negative 3. Yes, this is one part. But plus, I have to continue. So A2, so let me write. The area is this one plus. I have to start from here up to this point. So you see, I have to consider all these lines up to that point. Okay, so if I know that this is minus 3, I also need to calculate what this point is. So I have to start a new system, but with this one and that one. So this becomes y equals to x plus 12, and then I have y equals to x. And if I solve that one, I think you immediately realize that you get x is equal to 4. Okay, so this is 4. So I go from this number, which was minus 3, to 4. But can you tell me what should I write in the integral? So in this area, in this region, the curve above is this one. The curve below is this line. So the one above minus the one below is this one. Yes? And of course, this minus sign will be cancelled, so I just simply get this. It is completely doable, but it is a little bit time consuming because of even though the integrands are the same more or less, but the limits are different, so this is inevitable, so you have to calculate all of them one by one. Yes? Is that clear what I have written? I really recommend you to go home and try to solve that one. But now I want to teach you another perspective that you need to be ready to go back and forth between these two perspectives if it is needed. If you look at this problem vertically, horizontally, it is much easier because y equals to square root of x plus 12 and y equals to minus square root of x plus 12, they are the same. Yes, because if I raise it to power 2, this becomes y squared minus 12 is x. So x becomes y squared minus 12. If I square this one, I will get the same thing because when I square, the minus sign is gone. So this becomes y squared minus 12 again. So you see, on this vertical direction, I was facing two functions, one with the positive sign, one with the negative sign. But when I look at horizontally, so that I am interchanging the role of x and y, the first equation is this equation. The second equation is equivalent to this equation, but they are the same equations. Yes? So if you look at in this direction, so you write integral. So in this case, instead of looking vertically, now I will look horizontally like this. Yes? Like this. Okay? If I look horizontally, this one is above this one. Yes? This is farther to the right. So what I write this one first minus that one. But in terms of y, not in terms of x. So I would write y minus y squared minus 12. And then the whole thing dy, not dx. But because I'm going on the y direction. And now I ask you where y is going from to where. It's easy. You just need to calculate this and you need to calculate this length. Yes? So this is the y coordinate here. But we know it is easy because we already calculated this point. This point was how much was minus 3. I put minus 3 here. It also becomes minus 3 because x and y are equal. And if this is 4, that is also 4. So what I need to calculate is just one simple integral from minus 3 to 4. I recommend you to calculate this at home and calculate that one. You see what is the difference. But if you do the calculations right, the answers should match. Understandable here or no? So what I'm saying is that you are looking at this problem horizontally. So, and then you see that this thickness is no longer on the x direction. On the x direction, I called it dx. So on the y direction, I will call it dy. So I'm interchanging the role of x and y. That's it. Yes? Is that clear? Okay. So let us have a break until 6:20. So I can clean the board as well. Thank you. Okay. So let us just go to the next topic. That is also probably something you, in principle, know from your high school studies. So what do we mean by volume of revolution? So assume that you have a function in 2D space, in 2 dimensions. So this is your function, y equals to f of x. And then you have a region bounded by the x-axis, 2 vertical lines, and the graph of the function. So this area that you see is enclosed by these curves and lines. And then what you do, you take this region, an area, you start rotating it about the x-axis. This will generate a solid object, an object in 3 dimensions. That object, that solid, is called solid of revolution. And the volume of that object is called the volume of revolution. Yes. So it is very hard for me to draw the good shapes here, but what I mean, you take this one and then rotate it. So something like this, it becomes a shape. So a shape like this, yes. So you can imagine that. So if I start rotating it, it will generate a 3-dimensional object, which is called the solid of revolution, and its volume is called the volume of revolution. Okay, we want to use integrals to be able to find the volume of revolution of this object if I give you a and b, and if I give you the function f of x. Okay, So again, the idea is the same thing. So what we have to do, we have to try to slice this into very thin pieces so that I can find its volume, and using integral add them up. That's the idea, yes? So, but it is not hard to visualize this. For example, let us consider this point to be a point X, okay? So let me just draw a vertical line here. So you need to imagine it as a very, very thin rectangle, okay? So the width of this rectangle is what I call dx. Okay, now imagine if this very narrow rectangle is being rotated about this x-axis, it would generate a solid object. What that object is in this case? You imagine a very narrow rectangle that you are actually rotating it about one of its sides. It will generate a cylinder. Yes, is that understandable? Yes. Okay. So so assume that you have this, and you start rotating this about this line. It will actually, it will generate a disk, which is a very narrow cylinder. Okay, and then this length, after being rotated, will play the role of the radius of that cylinder, and this thickness will play the role of the height of that cylinder. Yes? And the formula for the volume is, if you know R and if you know H, the formula for the volume of this object, the cylinder, is pi R squared H. This is the formula for the area. Okay, so if I want to write everything like this, the thickness here is dx. Okay, this thickness, very, very small thickness here that you see, is dx. And now if I ask you what is this height, which will play the role of my radius, would be f of x. Do you agree? Because this function is f of x. If I want to know this height, I will go and find the x coordinate, put the x coordinate into my function, I get a number. That number is the height corresponding to that point x. So if I ask you what is this height, you will tell me f of x. If I ask you what will be the the volume of that thin cylinder, which I will call it dV, the volume of that thin cylinder is equal to the pi number, the radius squared. This will play the role of that radius. So this becomes the radius squared. Do you agree? So this will be the volume of that very thin, actually, disk after being rotated. And now if I want to find the volume, I have to integrate. So it means that the volume is the integral. Integral means adding the small numbers up, yes? So this becomes pi is a constant. I pull it out. Then this becomes f of x squared dx. X goes from a to b. So that is extremely important to be able to visualize why these formulas are correct, not just memorize them. So this is an intuitive way of understanding this. This will give me the volume of that object. Is that clear? Okay. So let me solve one problem at least for you here. For example, if I ask you to find a formula for the volume of a sphere of radius r. So what I give you a sphere, and I give you its radius r, and I ask you to find its volume. Yes? A sphere is from the beginning is a volume in the space. But if you want to use this method, you need to yourself imagine a curve, an area below that curve, so that after being rotated about the x-axis, it generates the shape that you want. Because this formula is only useful if you have a curve and that curve is being rotated to generate a volume, and this formula gives the volume of that generated object. So in this case, that I want to calculate the volume of a sphere, I myself should come up with a curve so that the area below the curve and the x-axis, if rotated about the x-axis, generates the sphere that I want to. Yes? So do you have any idea, for example, what to do? So I will take this semicircle, radius goes from minus r to r. So hopefully you agree that if I rotate this bounded region about the x-axis, it will exactly generate the sphere that I want. It will give me a sphere of radius r. Yes? So you might say that, okay, why don't you choose this one? Okay, from, I don't know, from, for example, 1 to 1 plus 2r. That is also, if I rotate this one about the x-axis, this will also generate the same sphere. But why I don't choose this, I will choose that, because if I choose this, the mathematics becomes more complicated. So the algebra becomes more complicated. So I want to somehow use the symmetry to be able to solve my problem simpler. Okay, but can you tell me what is an equation for this curve? If I want to write f of x, what should I write for this semicircle? Not 1. Square root of r squared minus x squared, yes? This is the formula for this curve. And then everything becomes very simple. So if I want to calculate the volume becomes pi. Don't forget about this phi. This pi is in the volume formula, but not in the area formula. So it goes from minus r to r. And then remember, I have a power of 2 here. So this gives me my function squared and then dx. Yes? So then this power of 2 will cancel that square root. It goes from minus r to r. And then I have r squared minus x squared dx. And then you have to calculate this integral. Okay, can you tell me what is the integrand? What is a primitive function for r squared? No, that is usually students make mistake. This is why I'm asking. What is a primitive function for r squared? No, r squared x. It's just a constant. Yes, it's a number. Yes, if I ask you how do you integrate this, you would tell me 2x, because 2 is a constant here. Here r is also a constant because that's the radius of my sphere and I cannot change it in the middle. Yes, so this becomes pi r squared x and then 1 over 3x to the power of 3. Be careful about this calculation. And then it goes from minus r to r. So I put r here. It becomes r to the power of 3 minus 1 over 3r cubed. And then minus, I put minus r here. So this becomes, again, pi minus r cubed plus 1 over 3r cubed. And if you calculate this one, it becomes 4 over 3 pi r cubed, which is actually what you expect. This is the volume of a sphere. You can calculate it so simple. Yes? Okay. And then I want to skip the other one. You can do it yourself. Let me just do the exam problem. So the exam problem is this. The curve y equals to, this is exam 2018. 0603, question number 3. So a curve is given to you, y equals to square root of 1 plus absolute value of x cubed. And then together with the lines x equals to minus 3 and x equals to 3, and y equals to 0, which is of course the x-axis. This determines a bounded region. Determine the volume of the solid generated by rotating the region about the x-axis. Okay, so if we know how to draw so this curve is a curve together with these two vertical lines and the x-axis will actually bound a region in a plane, and we want to rotate that region about the x-axis and we want to calculate the volume. Yes? So in principle, it's a good idea to have a sketch of the graph. But here in this problem, even if you don't sketch the graph and don't visualize it, just put it in the formula, it will give you the correct answer. So if you want to find the formula here, volume, you just write pi, and then the limits of your region is from minus 3 to 3, and then you square this function and dx. So what I have done, I have just put it into a formula. And then you have to calculate this one. So this becomes pi integral from minus 3 to 3, 1 plus absolute value of x to the power of 3 dx. Okay? But do you see, of course, it doesn't matter. This absolute value sign, I should be able to get rid of it. But if you just recognize that this is a symmetric, actually, interval, you need to remind yourself, might be the integrand is even or odd, because if you understand that, this will actually simplify the calculations. So which type of integrand is this? Do you think it's an even one or an odd one? What is the meaning of this question? You need to change x to minus x in your head. This becomes this function. But absolute value of minus x is exactly the same as before. So by changing x to minus x, nothing changes. So this means that this function is actually an even function. And if I have an even integrand and my interval goes from minus a number to the positive of that number, you can just multiply that integral by 2, but instead of going from minus 3 to 3, you go from 0 to 3. Okay, this is not, by the way, a minor simplification here, because if I do that, then I will be on the interval with positive values of x. Then I can also get rid of absolute value. Yes, so this becomes 2 pi integral from 0 to 3, and I can just remove the absolute value sign as well. Then it becomes a very, very simple integral. And this I don't calculate because that's very simple, so just calculate it. Yes? Any questions? Okay. But another formula that I want to talk about for volumes, I have seen that they have, for example, this problem in the exam. They have also, you need to know this formula for the area as well. Okay, so let us also understand the formula, okay? So what happens, this is the scenario. I have a region like this, exactly as before, for example. But this time, I want to rotate this region about the y-axis. Okay, so it is not attached to the y-axis. It might be or not be, something like this. So if I start rotating this, one middle part will be a hollow part. Yes, so that part which is included here is like a rim. I want to find the area of that, the volume of that rim, or I don't know how to call it in English. So you understand what I mean. Okay, so how can I do that? There is another method. So we want to find the volume layer by layer. Let us try to use your imagination. Okay, what I do, I will actually partition this region into very narrow rectangles. Very, very narrow rectangles, okay? So again, this width, I can call it dx. Now consider this very narrow rectangle, take it without changing this distance, rotate it about the y-axis. Okay, now tell me, in your imagination, what will it generate? Yes, it is a hollow cylinder, but can you elaborate a little bit how much hollow? I mean, most of it is hollow, yes, because it becomes a very thin layer of cylinder. Can you imagine that? Yes or no? Because you have this, I don't know how to draw it better. So if you take this one and if you start rotating this, this rectangle will generate a very, very thin cylinder, something like this. Something like this. I don't know, can you imagine something like this if I rotate it? Yes? Now, we want to find the volume of this very thin shell of cylinder in terms of what we have. So assume that this function is given to you. When I say this function is given, and I give you this x from here to here, I give it. When I give you this x, automatically you also know this height, which is f of x. Now, can you tell me what is the volume of that very thin layer of cylinder. You can imagine it in different ways, okay? But one way is to imagine that you cut this cylinder and open it up. Okay, what do you get? A rectangular cube, not rectangle, with a very small thickness. Yes, this thickness, by the way, what is that thickness? That's exactly dx. Yes, do you understand? But when because if that is exactly a cylinder, when I cut it and open it, I get exactly a rectangle. Yes, but if I have a thin layer of cylinder, when I cut it and open it, I get a very, very thin rectangular cube, not just rectangle. Is that understandable? So that this thickness will be also the thickness of that rectangular cube. Okay, can you tell me now, how can I find the volume of that? So you imagine it in your head. When I open it up, first of all, can you tell me this thickness is actually dx? Can you tell me what is from here to here? Look at this picture. In this picture, which one is from here to here? It is x, thank you. Okay. And then when I open it up, it becomes a thin rectangular cube. This thickness will be the height of that. I want to find the volume of that. So I have to find the area of the base and multiply it by the height. The height is exactly this thickness, so that is dx. Okay, now can you tell me what is the area? So assume that you open it up, okay? What is this height here? Can you tell me in this picture? F of x, yes? So when I open it up, one dimension of that rectangular cube is still f of x. So I have to multiply f of x by what? By this length, which is now one of the dimensions. Do you remember? If I open this up, it becomes a rectangle like this. This from here to here is f of x. From here to here, what is from here to here now? Before, this was actually the rim of this circle. I have opened it up. So this length from here to here is the circumference of that circle. Yes? What is the circumference of a circle? It is 2 pi, yes, multiplied by the radius. But the radius is x. If I arrange that, so dv is 2 pi x f of x dx. Yes? And then I integrate it to find v. So v becomes 2 pi integral x f of x dx from a to b. And that is the formula that you see on the notes. Yes? But that is the idea. So this is a little bit different. So you see that when I do this, I am generating one thin layer of volume. When I go to the next one, I will add another layer to the previous layer, and I am adding the volume of each of these layers so that I can get the volume of the whole solid object. Is that clear? Okay. So let me also solve this exam problem that you see on the board. So it is exam 2019 0607, question number 3. Okay, the curve y equals to sine x from 0 to pi over 2. So you have this famous sine curve from 0 to pi over 2. What you do, you rotate it about the y-axis and form a vase with volume v, yes? So let us understand this problem. Okay, so here is 0. I want to just draw the curve here exactly on this interval. Assume that this is pi over 2, and when I put sine pi over 2, it becomes 1. So this is the curve that I have. Okay, so it is mentioned the curve on this interval is rotated about the y-axis and forms a vase. Determine the volume of the vase. So which part do you think they mean? this part, because I think if you rotate this one, it will not generate a vase for you, yes? So I think they mean this, yes? Because if you just rotate this, it will generate something like a vase for you. Is that understandable? Okay, so this means that this is your area. The question is that I rotate this area about the y-axis, and I want to find the volume of that generated object, solid object. Okay, so I think now what happens, you can understand it yourself. So what I want, it is better to do this method layer by layer, yes, because I'm going around the y direction. But be careful, you have to be a little bit imaginative, yes? So you take another one here, and then you want to generate the formula. So if I ask you what is the dv here, so you see dv is 2 pi, so dv is 2 pi. X is what? X is, for example, from here to here, you call it x. So this is your x, and the thickness is dx. But f of x in this problem was this height. But in this problem, f of x is not your height, yes? Because if you say f of x, it will take you from here to here. But you want this to be your height. Yes, understandable? So, because in this case, you see, when I say the height of this cylinder, it goes from here to here. So you have to be imaginative. If I want to rotate this layer, the height is this much, but this much is not sine of x. From here to here is sine of x. From here to here is 1 unit. So the difference becomes the height. Understandable? So this becomes 1 minus sine of x. So this is the element of volume. And then you want to find the volume. So the volume becomes 2 pi integral x 1 minus sine x dx. X goes from where to where? From 0 to pi over 2. Yes? Understandable? So then you have to calculate this integral, which is not hard, because the first part is actually very simple. Integral from 0 to pi over 2 x dx. And the other one is integration by parts, which is a very famous one, so I don't want to continue. So you calculate, this is extremely simple, and that's integration by parts, and then you calculate and find the volume. But the only point that you have to be careful, if you just naively use the formula written, you will get it wrong. Is that clear? So you really need to understand which volume you are generating. Okay? So this is why I'm saying that in the previous problem, even if you were not careful, you just were lucky and the answer is correct. But in principle, you really need to understand what you are doing. Otherwise, you get it wrong. For example, if I ask you one more question here. So can you tell me how to look at this problem horizontally? Because this is the best way to learn about these things. If you want to solve the problem horizontally, how can you do that? So let me just draw another picture here for you. Okay. I want to rotate it about the x-axis. This was the layer method that I used. Now I want to use the disk method, but in the horizontal way. So what I can do, I can take this length from here to here. This thickness is dy. This height, instead of x, I call it y. And now I ask you, if you rotate this about the y-axis, what shape you will get? What shape? It becomes a disk, a very narrow, a very short, actually, cylinder. That is called a disk. And then if I ask you, okay, what is the volume of that disk? So what is the volume of that disk? I call it dV, is equal to the volume of the disk becomes pi, the radius squared, which is from here to here. Let me call it r for the time being. Radius squared multiplied by the thickness, which is dy. Do you agree? So this becomes the disk method rather than the shell method. Okay, but if I ask you what is r, so you need to tell me what is r. This function is y equals to sine x. Your thickness is dy. So r should be expressed in terms of y. But if I ask you what is this length, this is nothing except the x coordinate, yes? From here to here is x. Okay, so this means that x is arc sine of y. So if you want to calculate that, you can calculate it by this method. So if you want to use the disk method, this is the function that you have to integrate from where to where? From 0, y starts from 0, goes up to 1. So v becomes pi integral from 0 to 1 arc sine of y squared dy. I recommend you to really solve this one and then solve this one. The answers should be exactly the same. And that's also good to think, how can you calculate this integral? But my point here is not to calculate the integral. My point is to understand this is a correct formula as well. This is also a correct formula, but the strategies are different. Yes, this one is making the volume layer by layer. Okay, a full cylindrical layer, I add to another full cylindrical layer. But here what I generate a thin disk, and I put on these disks on top of each other to find the volume. Yes. And then subtract it. That's also possible. So what is you are suggesting here? Do you mean here, for example? So you say that, okay, let us consider this full rectangle. Yes, that's also the same strategy. So then I rotate this one, it will give me a cylinder, really. Okay, and then I calculate, instead of calculating this one, I calculate the volume generated by that one, and I subtract this volume from the volume of the cylinder. It becomes the volume of the waste as they want. Yes, but I prefer to solve it in this way because I want you to understand how to do this if the problem becomes a little bit more complicated. Any questions? Okay, we have a little bit of time, so let me also go to this arc length problem. So first, the formula for calculating the length of an arc. So for example, first of all, what is the arc length? If you have a circle or any curve, okay, so if I take this point and this point, if I ask you what is the distance between these 2 points, of course the distance is the shortest one is this one. But by arc length, I mean that assume that you really want to walk here, okay, how much you walk is the arc length, okay? So if you want to calculate the arc length, the formula is this. So L is integral, because we don't have time, let me just use it, okay? Integral from 1, the derivative of your function squared dx. Okay, so this is the function that I give to you, for example. I give you a function, and I give you 2 points from A to B, and I ask you, what is, if I start walking on this curve, what is the length, what is the distance that I have traveled along the curve itself? That is the length, arc length, that I want to calculate. So this tells you that if the function, by the way, here you have to be careful, the derivative should be continuous, not the function itself. Of course, the function itself is continuous, but its derivative should also be continuous. This will guarantee that this combination is continuous and therefore integrable. Okay, so here f prime should be continuous. Okay, you put this in this formula and you calculate and you find the arc length. So let me immediately solve one simple problem for you from the book. So you see you have this function y equals to x to the power 2/3, and then x between 1 and 8, you want to find the arc length. Yes? So what I have to do, I have to calculate the derivative first. So it becomes 2/3 x to the power of minus a third. Yes? And then you put it in the formula. So L becomes integral from 1 to 8. And then you have the square root of 1 plus this number to power 2, which is 4/9. And then you have x to the power of minus 2/3 and then dx. Oh, sorry, 2. Yes, that's correct. Usually the integrals are a little bit tricky, so you have to practice a little bit more than before. So do you know how to calculate this integral now? And by the way, most of the time we cannot calculate. For example, if I ask you, what is the formula for the circumference of a circle? You know it, yes? That is 2 pi r. But if I ask you the same question for the ellipse, you don't have any formula for that. Because the integral that it generates, exactly again for the same reason, the integrand does not have any primitive function among the functions that we know. So we have to artifact a function whose derivative is that particular function, which is called elliptical integrals. Okay, so that's what I'm saying. Usually the integrals that appear here are tricky. Okay, so do you have any idea how to calculate this integral? If I were you, I would get rid of this negative power because it is hard for our brain to think about negative powers. And I myself prefer to work with the surd sign rather than the fractional powers, yes? So let us try to see how it goes. So I would say that this becomes integral from 1 to 8, and then 1 plus, the first step, I bring this down, make it positive. Yes? And then what can I do? I can write it in this form. I can take the common denominator, for example. So this becomes from 1 to 8, square root of 9x to the power of 2/3 plus 4 divided by 9x to the power of 2/3 dx, yes? Okay, so at least the denominator is a complete square, so I can use this square root sign to get rid of this power of 2 here. So this goes from 1 to 8, and then I will have square root of 9. Here, what I can write the third root of x squared, and then I have a 4 here. And in the denominator, square root of 9 is 3. A square root of this, it becomes absolute value of this. Always absolute value. But I don't need absolute value because x is positive. Yes? So I remove it. So this becomes the third root of x dx. Do you have any idea how to calculate this? Let us test. Okay, so by just experience. Okay, so let us take u to be the third root of x squared. In that case, what is du? This becomes x to the power 2/3, and this becomes 2/3 x to the, that's good, I think. Because then I can write it as 2/3, the third root of x dx. Yes, and that's good. Because this combination appears, you see? This combination that I need appears here. So I need to divide by 2. So 1 over 2 du is 1 over 3 third root of x dx. And then, because x goes from 1 to 8, this means that u goes from where to where? If I put 1 instead of x, u becomes 1 again. If I put x 8, it becomes 64. The third root of 64 becomes 4. So this becomes integral from 1 to 4, square root of, instead of this expression, I just write 9u plus 4, and then everything else is 1/2 du. Yes? But this is now solvable. So this becomes 1/2 integral from 1 to 4 square root of 9u plus 4 du. And then you need another substitution. For example, you take t to be square root of 9u plus 4. And then what you do, you take t squared is 9u plus 4. And then you take the derivative 2t dt becomes 9 du. Okay, so this becomes equal to 1/2. Let us just do it a little bit faster. If u is 1, t is the square root of 13. If u is 4, it is the square root of 40. Yes? And then instead of that one, I just put t, and then instead of du, I put 2/9, which goes out dt. Yes? And then you calculate this. So this becomes 1/9, 1/18, and t squared. It goes from square root of 13, square root of 40. I hope that I haven't done any mistakes, but you can also check that 40 minus 13. So it is 27/18 is 3/2. Yes? So you see that even for such a simple function, the calculation is fairly complicated. Okay? Let me also solve this exam problem. We have a little bit of time. I think we can finish it. I will start with the left over, and then we go to the next module, which is infinite series, okay? So let me solve this exam problem as well. So this is y equals to ln of 1 minus x squared. We want to find the arc length between 0 and 1/2. Yes? So that's a simple problem. We have to calculate what we need. So first of all, we calculate the derivative. The derivative of this is minus 2x divided by y minus x squared. And then you have to calculate 1 plus y prime squared, 1 plus f prime squared. So it becomes 1 plus 4x squared divided by 1 minus x squared to power 2. I take the common denominator. Yes, it becomes 1 minus x squared to the power of 2 plus 4x squared. Always try to find the pattern that you get a square root, a complete square. This is a complete square, so that is good. But if you look closer, that is also a complete square. Why? Because if you raise it to power 2, and then you have plus 4x squared, this becomes positive 2x squared, and it becomes 1 plus x squared to power 2. Whenever this happens, it is very good, because then I have to take the square root, and the square root is good thing to do here. So the square root of 1 plus y prime squared is the square root of that combination. So this becomes absolute value of this one, absolute value of this one. Don't forget about absolute value. Of course, in this case, it is not necessary. The numerator is always, this expression is always positive, so I just remove it. But this one is always positive in this case, because I am between 0 and 1/2. So that's also positive. Okay, so the question mark is the integral from 0 to 1/2 that function. Okay, so what we can do here, because this is polynomial divided by polynomial, but the degrees are the same, so I have to use the long division. But this is simple, so let me just factor a minus sign out. It becomes x squared plus 1, and I flip them. We can use the long division, of course, it doesn't matter. But then I can write it as from 0 to 1/2 x squared minus 1 plus 2 divided by x squared minus 1. And then you divide this by that, which becomes 1. And then divide this by that, so it becomes minus 2 integral dx x squared minus 1, 0 to 1/2. Yes. This is trivial integral. That is also, we know how to do that. That's the partial fraction method, if you remember, yes? So this integral is just nothing except minus 1/2, the total thing. But here you need to write this x squared minus 1 as 1 over x minus 1 minus 1 over x plus 1. Do you remember? You write a and b and find a and b in the proper way. But if you calculate that, what happens? So this becomes minus, this becomes 1, this becomes 1 again, yes? And then I will have a 1/2 here, yes? So I calculated in my head, but you just write a and b and find a and b as before, okay? And then you put them back here. So this is possible to calculate, this is possible to calculate, that is already calculated, so you have your number. So something that you need to be careful is to be, so try to make a complete square, because if that's not a complete square, the problem becomes hard. Of course, this one designed by Adams was not a complete square at the end. The square root sign was left, but still we could do it. But it is very limited, so they have to fine-tune it in a very nice way so that you can solve it, okay? Otherwise, it is not guaranteed that we can always calculate these integrals, okay? So one thing that you need to look for if it is possible to make as many complete squares as possible, so to get rid of that square root sign. That's one rule of thumb here. Any questions?